Everybody, I am out of the building today. We have a HAL quiz bowl competition, and so I'm going to take the kids to that, and I'll be gone until seventh period today. So let me go through what you're going to do today. We've got two activities. The first thing is I'm going to take you through the first part of, well, actually, I want to review this page. If you guys remember last week, it's been a week already, we talked about the physical properties of matter, specifically mass, volume, density, and pressure. And I just want to review. It's been a long time. Let's just kind of remind ourselves what we're talking about and make sure, first of all, that you have all the information on this front page that you're supposed to have. And then I'm going to take you through, we're going to talk about Earth's outer layer, which is the crust. And then if there's any time left over, which there should be, you guys will have an opportunity to study your flashcards. And if that means that you need to make your review games, like if you're making your Gim kit or your Bookit or Kahoot or whatever you're doing, you'll have time to work on that in class. And then you'll also hopefully have some time to put into studying. Okay, let's get started. So actually, let me go back and clarify. I want you to have your notes ready, but because I want you to look at these. So go ahead and pause the video, pull these up on Good Notes, do a split screen if you have a digital copy, and if you have a hard copy, go ahead and pull those out, and then continue to play the video when you're ready to go. Okay. So physical property of matter, remember, these are characteristics of a substance that can be measured without changing its chemical composition. It won't become a different thing. We won't change it in the organization of the atoms that make up that object by measuring these physical properties. So examples we had talked about were color, hardness, melting point, and then mass, volume, and density. So remember, mass is the amount of matter that makes up an object. So it's all of the different atoms, all the stuff that makes up the object. And an object is going to have a lot of mass if it has a lot of matter in it. But the mass and the weight of an object are not the same thing. The mass doesn't change no matter where you are, but the weight will, because weight is a measure of gravitational force on that object. So next we talked about volume, and volume is the amount of three-dimensional or 3D space that an object or a substance occupies. So I had this picture of an apple, and I was like, okay, if we could somehow just pull that apple out of existence, and what was left behind was like a mold of the apple. This space, the three-dimensional space that apple occupies, that's its volume. And I wanted to talk to you guys about the mass and volume and how we can have maybe the same volume. So remember, the large circular space around is the same. So the volume is the same, but because there's more matter in the object on the right, that means that it has more mass. Okay. There are more red dots. It has more mass. And this can be thought of by the object on the left representing a basketball and the object on the right representing a bowling ball. There's more mass, more matter in a bowling ball. And so it feels heavier because there's more gravitational pull on that mass. Now I could have this where I have the same mass. So we have the same amount of matter, but the volume is different. The volume of the one on the left is larger than the one on the right. And I still don't like that picture very well. I think maybe what I should have done is spread the volume out a little bit more so they weren't so linear. I just don't like that, but I'm going to keep working on that example. All right, and all of this to say, I needed you to understand mass and volume so that you could understand density. And density is how much mass is packed into a given volume of substance. So the cube on the left has less mass so that it is less dense, and the cube on the right has more mass and it is more dense. All of that is so that when I start describing the layers of earth, and we talk about this one is more dense, or it is least dense, you'll understand that means it just doesn't have as much matter in that given area, that given volume. Okay, lastly, we talked about pressure. And if you remember last week, I showed the atmospheric pressure on a can by creating a vacuum inside. And then we saw that the atmospheric pressure pushed the can in. So pressure is the amount of force over a specific area. And we're going to talk about that a little bit later as we work our way into the cores, or into the inner layer, including the inner and outer core. Anyway, we'll talk more about that. I got a little distracted. Okay, now I want to have you guys take a look at the next page. This is what your notes look like. I've summarized my presentation. And so if you're going to try to fill in the notes as you go, you may find it a little confusing. So if I were you, I would just sort of put your notes off to the side and just watch the presentation, just listen to me, and then I'll go over this a little bit later with you, okay? All right, so as you know, Earth is categorized as a rocky planet. It's one of the 4 rocky planets. We have Mercury, Venus, Earth, and Mars. They're rocky planets. So what that means is it's composed primarily of hard and soft solid rock. So the very outer layer, it's called the crust, and then there's a thicker layer inside that's kind of, I'm showing it, it's like a red, really thick kind of orangish red. That's the mantle. And both the crust and the mantle are made of rock. The crust is going to be a hard solid rock, and the mantle is made of magma, which is a soft solid rock. And I have an activity later this week, probably tomorrow, that I'm going to use to demonstrate the difference between hard and soft solid rock. Okay, so there is a thin layer of water that covers the surface of the earth. About 75% of the earth's surface is water. Don't get that confused with Earth's outer layer is hard solid rock. The water and anything above that is called the surface. Okay, so the water sits on top of the solid rock. We also have vegetation, grass, trees. We have all kinds of like soil and sand and sediment that's sitting on top. Even in the ocean, you think about all the sand and the kind of muck and the stuff at the bottom of the ocean. That's actually sitting on top of the solid rock. So a thin layer of water covers 75% of Earth's surface, and of course some of that water is frozen. And I want to take a minute to just review. Hopefully you guys talked about the water cycle last year, and if you didn't, that's okay. We're going to review it really fast. So I have this tool here I wanted to kind of share with you. First of all, if you take a look at the very top left, you see a picture of the globe. And so the total water on Earth, of the total water on Earth, I said 75% of Earth's surface is covered in water. 97% of that water that's on the surf is the ocean. 97%. That's so much. And only 3% is fresh water. And of that 3%, the ice caps and glaciers make up 70% of that. And groundwater, which is like aquifers, water that seeps below ground and kind of is being held in underwater reservoirs, that's 29%. And the accessible fresh water that we have, that's fresh water that we can actually get to, is only 1% of the 3% of fresh water. It's crazy. We live on a planet that has liquid water, but we don't have access to drinkable, potable water all the time. We have to have it treated. It's just wackadoo. Later on in the year, you guys are going to be reading a book in reading class called Long Walk to Water. And I want you to remember this slide when you think about how some people really have to work to get their water, their drinkable water. We just don't have for a planet that has so much, 75% of the surface is water. We just really don't have a whole lot that we can drink. So if you look at that, I've got it circled, that accessible water, fresh water is only 1%. Okay. Of that 1%, some of that fresh water is inside soil. So the soil moisture is 38%. We can't access that. And lakes, 52%. Water vapor in our atmosphere is 8%. Rivers are 1%. And then we have water in living things. We have water. Our bodies are made up of water. Plants, animals, all living things have water in it. So that makes up about 1% as well. So it is remarkable how little water we actually have to drink, and yet it's enough. It's enough for us. Sometimes not enough for everybody, but it's enough for us to be able to sustain life, to be habitable. Pretty cool. All right, let me keep going. And then obviously the whole planet then is surrounded by a thin layer of gas called the atmosphere. And I found this picture. This was on NASA, and I absolutely love it. Typically, when you see a picture of Earth's atmosphere, it almost feels like it's light blue and it's kind of just going off into nothingness. And I liked this one. The photographer used it's not a filter. It's a way that you can take a picture and allow the light to be exposed a little bit longer, so you can really see kind of the different layers of the atmosphere. And it is absolutely fascinating to me that we have this atmosphere, and it's perfect to support life. It's not too heavy. It's so that, all of the carbon dioxide and all of the greenhouse gases and everything keep us and cook us, right? Like some of the planets, the atmosphere is so thick, it doesn't get, it's like 800 degrees and it's so incredibly hot, we wouldn't be able to live. And it's not too thin so that the gases just sort of float off the planet. And so it's just perfect. And I am so in awe every time I look at that. I think that's amazing. Okay. I want you to think about what Earth would look like if we could remove all of the water, soil, and vegetation off the surface. What would that look like? Well, I have a picture, and this is pretty amazing. That is Earth. If we could remove all the vegetation, all the water, everything, if we could remove it, that is Earth. And when I saw that for the first time, I thought, man, that is incredible, incredible. Think about Mars. And when we look at Mars and it's just a red planet, it's just solid rock. Think about Mercury, think about Venus, they're just solid rock. And so again, Earth is a solid rocky planet. Earth's outer layer is made of hard solid rock. And everything that we see on the surface of Earth is just sitting on top of the surface. So Earth is divided into 4 layers. Obviously, we talked about the crust and the mantle. And then going further inside, you have the outer core and you have the inner core. So the crust is what I want to talk about real fast. Super thin. It's made of hard solid rock. It is the thinnest layer. However, it's 5 to 100 kilometers thick. And what that means is it's about anywhere between 3 and 62 miles thick. So Lincoln is about 45 miles from where we are. So if you think about going to Lincoln and there's some parts of Earth that are 62 miles thick, it's pretty thick. And yet, in comparison to the other layers, it is super thin. And lastly, this is the least dense layer. So that means there's not as much matter in this outer layer as there are in the inner layers. All right, so remember the crust is broken into sections called plates. So this is an example here. I like this picture because it kind of highlights the different plates. If you look, can you identify Florida? So then you look over to the left and you can see, remember when we talked about the ring of fire? So just follow that plate boundary. The lines are called plate boundaries, and they indicate where one plate starts and the other plate ends. And over where we are, it seems like the plates aren't broken up into really small pieces. But if you look over more like around Africa and in Europe, you can see that the plates are, and even down, by South America, but Mexico, South America, um, we've got a lot of really small plates. So the crust is broken up into sections called plates, and the plates move. So here's another picture that shows, if you look at the red arrows, it shows you the direction that the plate is moving. And so I always like to just kind of orient myself with the North American plate. So find Florida. Okay, got it. There's our North American plate. And then the Pacific plate, that was where the Ring of Fire was, right? And if you go up along like California, see how those arrows are going in opposite directions, but they're kind of going side to side. That's called a transform plate. And then some of the arrows you'll see are going away from each other. Those are divergent plate boundaries. And some of the plates are moving towards each other. The arrows are pointing towards each other. And those are called convergent plate boundaries. And we'll talk more about those later. You don't need to write those down or anything right now. But three of the important key concepts that I want you to know, we're not being tested over them. But remember, Earth's outer layer is made of hard solid rock. They're divided into sections called plates, and those plates move. Now, there are two types of plates. They're called continental plates and oceanic plates. And I'm going to show you what they would look like. I'm going to go back to this picture. Continental plates are thick. So they're what make up the continents. And if you think about it, the ocean water is sitting on the surface of Earth, and the continental plates are so thick that the ocean doesn't cover them. These are actually less dense than the oceanic plates, which is interesting. And obviously, these make up the continents, which is the land that we actually live on. So these are called continental plates. And then the other type is called the oceanic plates. And this would be something like this. By the way, I don't know if you can see it, but where that arrow is pointing, if you can look over just a little bit to the left, and you almost see like a line kind of going up. And there's a line going up, but then also it looks like there's a lot of lines moving perpendicular to that. That is the Mid-Atlantic Ridge. And so this is what we would consider seafloor spreading. So the oceanic plates are thinner than the continental plates, but they are more dense. There's more matter in continental plates than there are more matter in oceanic plates than there are continental plates. And so if a continental plate and an oceanic plate would come together, the oceanic plate is more dense. It's going to be the one that sinks below the other one. And the oceanic plates make up the ocean floor. Okay, so that's all that I have for notes today. Let's check and make sure that you guys have everything filled in. So we've got the earth is the earth is composed primarily of hard and soft solid rock. I want you to go ahead and pause it if you need to pause it so you can write it. I'm just going to go ahead and keep plugging away. 75% of the Earth's surface is covered by a relatively thin layer of water, some of it frozen. The entire planet is surrounded by a relatively thin layer of gas we call the atmosphere. So the crust is the outermost layer of the earth. It is 5 to 100 kilometers thick, and it is the thinnest layer of the earth. The crust is the least dense layer, and the crust consists of many continental and oceanic plates that have slowly moved and changed positions on the globe throughout geologic time. Make sure that you have these notes, and then when you're finished, I want you to go ahead and work on your vocabulary. I gave instructions to your sub that you are supposed to finish creating your game. Whatever it is, your review game that you want to create, you have to do that. And then if she gives you permission, you may play with, have a couple people play your game or you play their game. But I want you guys to be respectful, please. Do not be loud and crazy. Let's have some organized chaos and spend some really good time reviewing those words. All right? Okay, you guys, take care. I'll see you tomorrow.